So this, we are going to start the third way to do find our rate law. And this time, we are going to be using graphical. This is going to be a graphical method. And these are called integrated rate laws. So here you have your reactant and then your products. And what we're going to do is we're going to write the rate law, and we're going to integrate the rate law. So we have the rate law, which is rate is equal to K times the concentration of A. This is what we're doing right now, zero order. So this is for the zero order reaction. And so what happened is somebody took the rate law and they integrated it, okay? And they integrated it from time 0 to time t. And when they integrated this, they came up with the following equation. They came up with the concentration it died on. Okay. The concentration of A minus the concentration of A at time 0 initially. And that was equal to negative KT. T being your time. This is something you are just going to have to memorize. It is not on your equation sheet. Okay? And they call this the integrated rate law. What we can do with this this integral is we can linearize it. And when we linearize it, what we do is we take our concentration of A, and that will be equal to negative KT plus our concentration of A at time 0. So what's this look like? Y equals mx plus b, right? So what we can get from this is we can get our order, and we can find the rate constant. And our rate constant would be our M, or in our calculator it comes out as A. Okay, so when we graph this, our X is going to be time, is always going to be the time. And what is our Y going to be? Our Y is going to be our concentration of A. Now, when we do this, you see that you have negative KT, so our slope is going to be negative like that. But remember, trying to zoom in. K cannot be a negative. You cannot have a negative rate. So you're going to take the absolute value of your M, and that is going to be equal to K. So our slope, absolute value of our slope, is our rate constant. Everybody good with that? You need to be able to graph it, look at a graph, and say, oh, that's zero order. Any questions? All right, I'm going to skip this little part right here. I'm going to come back to half-life. Let's go ahead and look at first order. Okay. What is the problem with the internet today? It's been like that for 2 days. I need to email somebody. So this is first order. And this time, again, they integrated it, the rate law, from time 0 to time t. And when they integrated it, they came up with the following relationship. They said that the concentration of A, ln of A, ln of A minus ln A naught, our initial, is equal to negative KT. Again, you linearize this and you get ln of A is equal to negative KT plus ln of A naught. Again, you get y equals mx plus b. Why did that? This has moved down on me. And this is on your AP sheet, so you do not need to memorize. But it's not labeled as being first order. They just give it to you. So if we were to graph this, we have T over here. Why? I have no idea why that moved on me. I'm going to have to write up there. And then what is on our y-axis this time? The actual log of concentration of A. And this time, it looks the same way. Oh my goodness, I have no idea what is wrong with this. You have the negative slope. And then you have M. The absolute value of M is equal to your rate constant, K.
So will K always be negative?
You don't have a negative K, so you're going to have a negative slope,
Yeah.
but K is always positive. We just take the absolute value of the negative slope. Again, I'm going to come back to this slide and talk about half-life for first order. But are there any questions of this? So you need to know what your x-axis looks like to be able to tell if it's first or second order. Okay, this time let's go to second order. So we have second order. Again, we integrate the rate law, integrated at time 0 to time t. And when they did, what they found out was, and this is on your AP sheet too, that 1, the reciprocal of the concentration of A, minus 1 over the initial concentration of A is equal to KT. This time it's positive KT. Clean it up, and this time we get 1 over the concentration of A is equal to KT plus 1 over the initial concentration of A. So how would we label our graph this time? We have time, and our y is what? 1 over concentration of A. We have a positive slope, and M equals K. So this is one of the ones where it's the only one that has a positive slope out of the 3 that we're dealing with. So it should be easy to see.
So does 2 pi 4 have positive
We really don't even look at anything after 2, so. I really haven't. I think they do. But I haven't really ever looked anything past 2nd. All right, so if you look on your next page, or at next, you have the summary of all of those, what we just went through. And here is here's how to make it a little bit easier for you. I'm just going to go ahead and draw all 3 of these on this one little section. Okay. And we have 0 order, 1st order, 2nd order. What is the x-axis label? Time. So all of these have time. On the 0 order, what is the y? Concentration. And on the 2nd or 1st order, what is it? Natural log, ln of A. And on the 2nd order, it is 1 over A, or the reciprocal. So we can make this clear for you. So clear, concentration, ln of A, 1 over, or the reciprocal. So it is, so think of clear when you're thinking of those graphs and what they look like. And then remember, the graphs look like that. So I'm going to go back to half-life. So I'm at 0 order half-life. And when we think of half-life, what do we think of? Half what? What is half-life? How long it takes for half the concentration of something to disappear, right? Okay, so every reaction has a half-life. And all reactions have different, depending on how fast or how slow they disappear, depends on the half-life equation. So I am going to take the 0 order equation, and what I'm going to do is, at time A, if we're talking about half-life, or at concentration of A, if we're talking about half-life, how much is that? How can we rewrite that? How can we rewrite A? A is going to be equal to 1/2 of our original concentration, right? Everybody agree with that? So what we can do is we can substitute, and I'm going to drop the brackets just to make it easier. We can substitute this, what we just wrote here, back into A. So I'm just going to write this as A naught over 2. That's the same thing as this right here. I just made it a little bit cleaner. And I am going to subtract that, everything else that we've already written. And what I'm going to do is I'm going to put 1/2 here at the side of T, because that's at time 1/2. Everybody okay with that? So what we can do here, how can we make, so A naught, another way for A naught is 2 over 2, right? Everybody agree that we can have 2 over 2 so that we could put those together? And when we do that, we end up with negative A naught over 2 is equal to negative KT at 1/2. What we're going to do right now is we are going to actually just solve for T. So, well, no, not T, because that's just a subscript. That's, instead of like A naught, that's T subscript 1, 2. So now let's clean it up further. So time, so a half-life of a zero-order equation or reaction is a concentration, my original concentration, over 2 times the rate. Okay, so if you're given half-life and they ask you to solve for time, then you can also, instead of, because they don't give you this equation, what you can do is just, if you have, what's the concentration of at half-life if you're of your original? If you originally started out with 100, what's your concentration halfway for your half-life? What's A going to be? After half-life, if you start out with 100, A is going to be what? 50. So you can either use the equation and memorize it, or you can go and know your zero-order rate law, integrated rate law. Again, you have to memorize that, though. Okay. Now, if we go to first order, you are given first order rate law, and so all you have to do is remember, just drop the ln, and that gives you zero order. So if we take ln of A minus ln of A naught and equal that to negative KT. Now what you need to know about first order reactions, all radioactive decay is first order. What?
Is there a way to write this in an exponential form?
I have no idea. Okay, so remember a while ago we did A naught over 2 is equal to A. We're going to do that again, and we're going to substitute that in. So now we have ln of A naught over 2 minus ln of A naught is equal to negative KT at 1/2. When you subtract natural log from a natural log, what are you really doing? That is just ln A over 2. You're really dividing, right? And we're going to set that to negative KT. One-half. Clean it up a bit, and what we get is ln of 1/2 is equal to negative KT at time half. Everybody in your calculator later take the natural log of 1/2. Negative 0.693 is equal to negative KT 1/2. So what we can do is clean it up, and T of 1/2, so at half-life is going to be 0.693 over K. This is on your AP sheet. So they give you this. You just have to recognize that that is a first order reaction.
Is it?
Everybody good? You ready to do some problems now? Get your calculators out. We're not going to do half-life for the second order. Okay. Again, here's all your information I just gave you. Let's do some work right here. Decomposition of hydrogen peroxide to water and oxygen follows first order kinetics with a rate constant of 0.0410 minutes, 1 over minutes. So that's my K right there at a particular temperature. And there is our equation. So we cannot write our rate law from that equation. What we need to do is, it wants to calculate the concentration of hydrogen peroxide after 10 minutes if our original is 0.2 molar. So let's go to our integrated equation. Ln of A is equal to negative KT plus Ln of A naught. So the Ln, hydrogen peroxide concentration, is equal to, what's our K value? So negative 0.0410, 1 over minutes. How many, what's our time? 10 minutes. And plus the natural log of our original concentration, which is 0.2 molar. So we get Ln of H2O2 is equal to, what do you guys get for the right-hand side?
Negative 1.199.
Is that what you got? I got something different, but
I got negative 2 point.
I got negative 2.019.
Yeah.
Negative 2.019. So now let's solve for the natural log. So we're going to take e to the raised, right? And that it leaves me with H2O2. And then take little e to the power of negative 2.019.
You said e to the negative.
Yeah, the little e.
Yeah. 0.1327.
0.133 molar. Everybody good with that?
So why did we use the e?
Because the opposite of natural log is that function,
Oh, okay.
the little e. Y'all ready to do one more?
No, I'm confused on how I got the math part wrong.
Huh?
What you did.
Well, just so it's 0.041, negative 0.04 times 10 is negative 0.01.
Oh,
And the
okay.
Ln is
So-
0.2.
Yeah, why is
It's not negative.
negative?
Rate is not negative. It's a negative slope, but you take the absolute value for rate
And you have negative
in the equation. Okay, let's do one more. Okay, so this time the decomposition follows first order kinetics. Initial concentration is 1.25 times 10 to the minus 3 and then falls to 1.02 in 100 minutes. Calculate the rate. So now we want to calculate K. So first order kinetics says ln of A is equal to negative KT plus ln of A naught. We can come back and we can say ln of A over A naught is equal to negative KT. Because remember, this time we're solving for K. So you're going to take the natural log of 1.02 times 10 to the minus 3 divided by 1.25 times 10 to the minus 3 and set that equal to negative K. And this time is 100 minutes. So solve that and get me a value for K. What'd you get, Andrew?
0.002.
0.03?
Or, yeah.
Okay, that's what I got too. 0.00203. This is first order kinetics. What is my unit? Remember, 1 over time, and then molarity to the overall order minus 1. So our overall order is what? 1. 1 minus 1 is 0. So my unit is 1 over time, or minutes to the negative 1. Everybody good? Let's do the last one, and then we're going to go to the graphing. I like the graphing better. In problem number 9, how long would it take for the half-life of hydrogen peroxide to decompose? So what is the, what order was problem 9? First. So my equation is T1 half is equal to 0.693 over K. 0.693, and K, they tell us, was 0.0410 minutes to the negative 1. So solve for T1 half for me.
T1.
16.9 minutes
Equals T1 half.
equals T1 half.
Multiply that by 2.
Nope, that's right. We're not multiplying by 2. That 1 half is just letting us know that we're looking at half-life. Okay, there's 2 more examples. I'm not going to work those. I want to just go ahead and get into the graphing. You will like these as much as I like them. Very first step is turn your calculators on and make sure your diagnostics are on. So you're going to do, just go to second 0 to bring up your catalog.
Okay.
And then go hit the alpha button and go to hit alpha D. And then go down, just skip down to diagnostics and hit diagnostics on, and then hit enter, and it should say done. Okay, so now we have this time. We have our time, and time is always going to be our x, and we have our concentration. So the first thing what we're going to do is you're going to hit stat, edit, and under L1, put in all your time. So 0, 2,000, 5,000, 7,000, 11,000, and 15,000. Okay? Now, go to L2. L2 is going to be our concentration. So go in and put in all your concentrations. So 0.0015, 0.0014, 0.00127, 0.00118, 0.00103, and 0.0009.
So the first one is 0.0015.
0.0015.
0.00?
Mm-hmm.
I thought it was too clear. Oh, yeah, it's
Okay, so L2 should be complete. Now go to L3 and go up, arrow up until the L3 is highlighted. And what we're going to do is we're going to do this time LN of our concentration. So you're going to hit LN, and then this time you're going to hit second 1. So it should, or not 1, sorry, second 2. So it should say LN open parentheses L2, and then hit enter. So now we have our natural logs of all of the concentrations. Now go up and go to L4 and make sure L4 is highlighted. And this time you're going to put 1 over second 2. So it should say 1 over L2 and hit enter. Everybody good? L2. So your first number should be 666. Okay, so now what we're going to do,
Can you repeat what we do for L3 and L4?
L3, yeah. So for L3, you get it highlighted, and then you're going to hit LN, and then second 2. And then you go to L4, and you're going to highlight L4, and you're going to put 1 divided by second 2. Okay.
one or just one?
Huh?
For L4, list one or just the numbers?
You need L2. You need the second. Second 2.
Yes. That first number, is that the number one or is it list one that you're dividing it by?
Number 1. Okay. Everybody good? Now hit stat. Calculate. Lin reg. Enter. You're going to do L1 and L2. And this is going to give us our first order. Or 0 order. Sorry, 0 order. So, 0 order. So, our M is -4 times 10 to the -8. Our B is 0.00148. So you need to get your M, you need to get your B, and you need to get your R squared. Our R squared is 0.994469. I just go out about 6. All right. Do your Lin Reg for your first order. So this time we're going to do, I always just hit second enter or second enter, and that brings up my last function. And I go and change L2 to L3. And this time my M is negative 3.41 times 10 to the negative 5th. My B is negative 6.5, and my R squared is 0.999896. Huh?
Why did you get to that?
How do you change L1 to L3? And
Oh, how do you, okay, so L1 to L3? We're just messing with L2. We're just messing, okay, so did you hit second enter? And that brings, so just arrow over to L2, and this hit second, and then 3 for L3.
Is your X was supposed to be L1 and your Y was supposed to be L2?
No.
And you tried to click in the percussion?
Wait, let me see.
Guys, when is that? I got something totally different.
It should always be L1, L2, and then L1, L3. L that. Calculate. Hold on, let me pause this.
So like,
Next thing we want to do is we are going to get our second order. So this time you're going to do second enter, change the L3 to L4 by hitting second 4. Hit enter. And this time my M is 0.0296. My B is 652.22, and my R squared is 0.99428. All right, so we've got all this data here, all this information. What order is it? Who has the best R squared? First order. So your best R squared is what order it is. So we've determined the order. Now it wants to know what the K is. So K is equal to, and in this it is 3.41 times 10 to the negative 5th. What's the unit for first order? One over time. So second to the negative 1, or 1 over second. The other part of the question wants to know what is the rate law. So rate is equal to K times the concentration of N2O5 raised to the first power. Okay, so what I want you to do right now is to go over and work the next list of your data and tell me what you get.
Or no, L3 is,
Okay, so we figured out it's second order. K, the value is K of K is what?
Like 5 4
5.547, we'll say 8. And what's the unit? If it's second order, then the unit is what? 1 over second. And what else? M. And the rate law is going to be rate is equal to K. And you can substitute K in there since we've already gotten it. And then it would be times the concentration of NO2 to the second order. Any questions over that?
It's a lot easier.
It is a lot easier. I love doing these.
Confusing when you were talking about the calculator.
Just
I thought you did it great.
I'm just